Hey YouTube, hi guys. It's pretty late and I've been meaning to upload this video for some time now. I probably mentioned it in one of my other previous videos, but as you can see by the title, this video is about a gene mutation that certain small percentage of the population carries that's called Delta 32 or the CCR5 gene mutation. And the reason why I wanted to educate some of you guys about this is because a lot of people don't know about it, surprisingly, because it's not discussed a lot. And the people that are born with this particular genetic mutation are resistant and immune to HIV. And I'm gonna go over it with a little bit with you because I have an old PowerPoint here that I had from college days that it's a couple years old, but I'll still kind of walk you through some of the PowerPoint. But let me give you a little back history before I get into it. But I'm not sure if any of you are familiar with any of the news. You may have heard of a Berlin patient, a guy in Berlin, maybe I would say a couple, 7, 8, probably 10 years ago about. His name was Timothy Brown. He was one of the first patients that was cured of HIV. He had had it for about, I think, 15, 20 years. And it was actually accidentally done because he had a stem cell transplant of someone who had the Delta 32 CCR5 gene receptor, and it cured him accidentally. They didn't know. They just checked his viral load and everything months later, and he didn't have HIV anymore because he was given stem cells from someone with the CCR5 gene mutation. And I'm going to explain to you guys how this works. So I don't want to talk about but in the ending, I'll tell you about the additional. To date, there are now 4 people who have been cured. And this is not to be confused with the elite controllers, which is totally different. Those are people who live with HIV for years without medication, and basically they their viral load can stay undetectable. Totally different. We're talking about HIV resistance here. Now, this was originally found because during the early 19th century, there were a lot of people that they wondered why they survived the bubonic plague. A lot of people died, but there were a couple of people who did survive, and they were in contact with it and everything. So they basically took a gene pool of these people to see what likeness they had, what was so similar about them. Why did they survive? When all of these people were dying, why did they survive the plague? And they found one thing in common, which was this genetic mutation, which is Delta 32, which happens to be the same genetic mutation that makes people resistant to HIV. So those of you, I'm going to show you this PowerPoint here, which is called HIV Immunity. Now, we all know most of us know how HIV is transmitted, which is unprotected sex, pregnancy and childbirth, and breastfeeding, although now there are ways to prevent that. The injection of drugs, working in healthcare, meaning being accidentally stuck by needles, blood transfusions, organ and tissue transplants. Now, how does HIV enter the cell? HIV enters the cell through chemokine receptors, CCR5 and CXCR4. Some of you are familiar with those receptors and you know them as the CD4, CD5 cells. On the surface, and they also enter on the surface of host immune cells. The method of entry for the HIV-1 virus to basically infect the cell. Now, these statistics are rather old. It's about 7 years old. This is since 2014. It's just showing the new HIV diagnosis by race and ethnicity. As you can see that the African American community has the highest, and Hispanics and Latinos. And you could see the lowest are amongst American Indians and Native Alaskans. What is a genetic mutation? So for those of you who are wondering what a genetic mutation is, what is Soy Sweet 99 talking about when she says genetic mutation? A genetic mutation is a mutation is defined as a permanent inheritable change in DNA-based sequence. Those of you who may have taken courses in anthropology, these are things that we inherited throughout time, and this is part of adaptation, which allows a species to survive. Genes and cells change and they mutate frequently. We even have mutations for different eye colors. Okay, so the next slide is just a DNA helix here, and it just shows you that. So what is the CCR5 Delta 32 mutation? It is natural resistance to HIV infection linked to a DNA mutation, and HIV entry is inhibited because of the absence of the functional co-receptor CCR5. Now, how does that work? Now, in this illustration here, you can see, barring the door, how a mutation can protect against HIV. Okay, so in this picture, you see here, this is a white blood cell. This is the HIV virus. This is actually what it looks like under a microscope. Not just like, but similar. And if you can see that on the surface of the white blood cell, there are CCR5 receptors. And you can see that the virus enters through that route. Now, if you look at this person right here to the right, these are the Delta 32 CCR5 people with the genetic mutation. To enter a cell, one thing that most HIV strains must do is bind to CCR5. You see they're binding to CCR5 to get into this semi-permeable membrane. A molecule that protrudes from the cell surface. So this is what they're telling you. There's no molecule here to get inside of that cell surface. So it says that without CCR5, some people are born with a mutation that prevents CCR5, which is this receptor, from appearing on their cells, making them resistant to HIV. Some experimental gene therapy approaches aim to mimic this mutation in AIDS patients. Now, those experimental approaches they're speaking of is ART, HIV medication, that basically mimics this. This is how we are able to have a lot of patients taking only one pill a day now. So here's another illustration where it shows what HIV infection looks like. And that's the CD4 receptor, the CCR5 receptor. It's showing that both receptors are needed for HIV to enter into the human cell. And this is no infection. So it shows that the virus here is above and it's trying to enter this cell. It shows that this person that is born with this mutation has the CD4 receptor, but they don't have CCR5 Delta 32. So I want you guys to notice that that is an important fact. You have to have both CD4 and CCR5 in order for the HIV virus to enter your cell. With the absence of the CCR5, in most, which is 98% of strains, it will not enter into the cell. So, question. Who is born with the CCR5 32 and Delta 32 genetic mutation on their cells? It's actually, on this slide, I have, because this is dated, like I said, a couple years, 1% of Caucasians have it, and it's even rarer in Native Americans, Asians, and Africans. A 2005 report indicated that 1% of the people descended from Northern Europe are virtually immune to AIDS. But here's the thing. This has been updated and it's now roughly around 2%. So they're going into it more. And just because it doesn't necessarily mean Caucasian, fully Caucasian, but anyone probably descendants of those people. So this, I wanted to talk to, this is the man that I mentioned, that Timothy Brown was the first person to be cured of HIV infected with HIV during the 90s. And he was treated with HIV medications from 2003 to 2007. He was accidentally given stem cells from someone with a genetic mutation. This is him here in this picture. So he's still HIV negative till this day. And like I said, this was an accidental approach. So the future right now, the HIV treatment is that they're aiming to get blood from persons with the CCR5 Delta 32 genetic mutation. Being that there's not a large amount of the population, this would be kind of rough. And antiretroviral medications that can copy what Delta 32 mutation does. So I'm going to turn the camera back to me here. So anyway, guys, I just wanted to go over that with you really briefly because there are a lot of people that don't know about it. This information is available to all of us. And there are so many people that don't know that people are born, just like with any disease, even with COVID, we don't really know what mutations make people resistant. to it. It's just like if you think about the Atlantic slave trade, and the reason why they brought many Africans over here was because the Europeans kept dying due to malaria, so they weren't able to build up the Americas. So once they saw that the Africans were resistant to malaria because they had sickle cell trait and sickle cell disease, that sickle cell trait and disease is a genetic mutation. So in one form sense, it may not allow the red blood cells to circulate rapidly throughout the bloodstream and throughout the system, but that mutation also benefits them in the form of the sense that it protects them from malaria. So it's just like the Delta 32 CCR5 genes. It may be there for a specific reason, and there may not be a benefit in one case, but it also will benefit them in another. And that happens with a lot of diseases, and I'm going to get into that a little bit more when I make my video about COVID and discuss to you about natural immunity versus vaccinated immunity and how that works. So anyway, you guys feel free to comment below if you know of anyone. Some of us probably know people but don't know, because you would have to get a special test to see if you have this immunity. But this has nothing to do, once again, with long-term survivors or people who develop symptoms later on. This is not anything in relation to Delta 32. However, you do have people who have one copy of the gene. I can't think of the young man's name at this point, but there was a family, I believe it was in the Midwest somewhere, and the entire family died of AIDS. But their son, he survived. I remember it was in the news back then. And come to find out, he had one copy of the gene. So there are people with one copy where they can still be infected, but it doesn't provide them with the full immunity as if they have both copies of the gene. So anyway, feel free to comment below. You can share your journey, your story. Let me know how it's been for you. And please like and subscribe to this channel. Thank you and have a wonderful day.